Everyone, so today we're going to continue with compound inequalities. Today specifically we're going to be looking at OR compound inequalities. Yesterday we did a quick review of what they are, and I showed you both kinds, but today we're going to go in deep with the OR inequalities. Okay, so let's quickly review how to solve compound inequalities. So step one is you solve each inequality separately. And then step two is you're going to graph to determine solutions. And you're looking for places where neither inequality encompass. I'm just going to put a question mark there, just so you can think about it as like when you graph them and you'll see, you know, like one line might go this way, one line might go this way. Are there any places where neither line interact with? So let's work through some examples. So first one, negative 8x plus 14 is greater than or equal to 60, or negative 4x plus 50 is less than 58. And so what we're going to look for here is what solutions meet this whole thing, where x can be this or x can be that. So first step is I'm going to solve each separately. So here we get negative 8x is greater than or equal to 46. Then I'm going to divide both sides by negative 8. I get x. Since I divided by negative, I now need to flip my sign, is less than or equal to negative 46 over 8. And then we can reduce this. You can leave it in fraction form. I'm going to also convert it to a mixed number just so I know on my number line where it needs to go. So both of these numbers are divisible by 2. So I get x is less than or equal to negative 23 over 4, or 4 goes into 23 5 times, and then there's 3/4 left over. And I didn't really need to figure out the 3/4, I just needed to know it goes around somewhere near 5. And so then on the other side, negative 4x is less than 8. Divide both sides by negative 4. And here I get x. I need to flip my sign, is greater than negative 2. Okay, so now I'm going to graph to solve. So right now, what I'm saying is x can be less than or equal to negative 23/4, or x can be greater than negative 2, but there might be a quicker or an easier way to write it so I'm not being redundant. So that's why we graph it, to figure out, you know, is there actually any solutions? Are the solutions infinite? Is it kind of what we said it was originally? So let's graph. Okay, so this inequality here says x needs to be less than or equal to, so that'll be a closed dot, somewhere around negative 5. So it doesn't need to be perfect, but I'm going to put a closed circle, and then it needs to be less than, so I'm going to go this way. And then for this one here, x has to be greater than negative 2. So I'm going to put an open circle. I'm going to go this way. So when I graph, what I'm looking for are there any places that neither inequality interact with, which is right here. So x cannot be anything between these numbers, but it can be anything above negative 2 or anything less than or equal to negative 23 over 4. So my answer would be, or my solution would be, x is less than or equal to negative 23/4, or x is greater than negative 2. Okay, let's do another one because that one you might be thinking, well, why do I have to graph it if it's just, obviously it's this or this. And so we're going to go through ones where that might not exactly be your answer. Okay, so next one, 3x minus 8 is less than or equal to 23, or negative 4x plus 26 is greater than or equal to 6. So I'm going to start by solving. Here I get x is less than or equal to 31/3, or if I just, so for graphing purposes, I know it's 10 1/3. And then on this side, minus 4x is greater than or equal to negative 20, divide by negative 4. My sign has to flip, and so I get x. It was greater than, now it becomes less than or equal to positive 5. Okay, so now I'm going to graph. And when I'm graphing, I'm just looking for, like, okay, I need 5 and 10 to be in there, so I'm going to go between 4 and 11. We're going to go up to 12. Okay, so for this one here, we're going to graph first here, and it says x is less than 31/3, or like 10 and a little bit. And it can be or equal to. And then for this one here, x is less than or equal to positive 5. Okay, so here, my solution, you might be thinking, well, couldn't you just say your solution is this or this? But when I write it like that, it's being redundant because this is included in this, because this is saying anything less than 10 1/3, which includes anything less than 5, since it can be or. So my solution here would be x is less than or equal to 31/3, because since this is or, it includes 5 in here, so I don't need to say or less than 5. So this would be the correct answer. Okay, let's do one more. 5x minus 19 is less than or equal to 1, or negative 4x plus 3 is less than negative 6. So again, I'm going to start by solving both. X is less than or equal to 4, and then on this side, and here I get x, my sign flips, is greater than 9/4, or just so I know where I'm graphing, 4 goes into 9 2 times, and then there's 1 left over. Okay, so now I'm going to graph. And both of these are positive, so we're just going to go, I'll just go 0 to 5. And we'll go 0 to 7. Okay, so here, let's start with this one. X is less than or equal to 4. And then on this side, we have x is greater than 2 1/4. So we'll go there. Okay. So, unlike in our other ones where there were places where neither encompassed, here both inequalities combined encompass every single number, which means that my solutions, so if we were in Khan Academy, the correct answer that you would click, it's really infinite, but all values of x are solutions. And so when it comes to not possible solutions, So whenever you're working on the OR ones, whenever you get that kind of a problem, just know that when it comes to these, there's not going to be such a thing as no possible solutions. And then because it's OR, you're probably also not going to see a solution that's like 2 is less or is greater than x, which is less than 3 or something along those lines. But this one for sure would not be included. So already if you want to do process of elimination, since all these are going to be multiple choice, no possible solutions. If it's an OR inequality, never true.